Hello everyone. In this video we're going to start with the warm-up, which is the metric prefixes classwork. So this is the answer key here. It is in the PowerPoint, so I will be sending that through the chat. Let me show you how we would do this assignment. Most of you guys probably already know how to do this. So we're going to we click on the link. It tells us to make a copy. I click the make a copy button and it pops up. Up here it says the metric prefixes need to be memorized. You don't need to memorize them, so I cross that out. And then down here it says no prefix is ever used alone. It's always attached to a unit of some kind. So centi and then meter, milligram, something. There's got to be some kind of unit. So what we can do is we can open this here and then have this in a separate window, right? And kind of split them, right? Something like that. And then I would click on where it says answer, and I would type my answer. The abbreviation for giga is G, so I would put G there, and so on. Okay. If your scientific notation doesn't look exactly like this, it's fine. If I go ahead and do it, I'll show you how to do it correctly. 1 times 10, and then the way that I type this 9 is, I guess I can try this. Oh, let's see, that doesn't work. We can hit Control and Shift and the plus. Oh, that doesn't work either. Okay, well, we can just do that to the 9. We can do that. That might be a way to do it. Let's see if I can try another thing. Grab that, format, text, superscript. So if you want to make it a superscript, you can. You don't have to. You can just do 1 times 10 and then just put a space and then 9. And I know that means 1 times 10 to the 9. That's fine. Or you can put the little caret in there, something like that. All right, when you're done, we're going to click share. Type in EMENHISER. I should pop up, but make sure before you do that, change link to Garland ISD. All right, so let's start this over. Let me lock it back and I'll show you. Make sure we do it right. So once you're done, your document will be locked. Click share, click change link to Garland ISD, and then up here, you want to click up in this area. All right, EMENHISER, boom, and then send. Okay, or you can send it through Canvas. Okay, so we'll do that first. All right, and then we will do our test review. Okay, so metric prefixes classwork was what we just were looking at. We're going to watch this video, Unit 1 review video, and then you students will complete the Unit 1 test review. And then we'll be doing this later. So if you can get the Unit 1 test review done, that'd be good. I'm looking at doing a lab equipment scavenger hunt pretty soon. So the requirements for day 13, which is today, for A day, it'll be Monday, September 14th. B day, it'll be Tuesday, September 15th. But it's day 13. In-class participation requirements. Students must complete the Unit 1 review, the Unit 1 test review, and the metric prefixes classwork during the day, okay, by midnight to receive credit. Okay. So today we're going to do our review. I'll do some of it with you, and then I will give you some problems to do on your own. That'll help prepare you for the tests. If you don't practice it on your own, you're not going to make mistakes, right? You won't have the chance to make mistakes early. So if you make mistakes now, then you won't make them on the test. So today is the test review. Thursday, or I guess for you guys it'd be Wednesday, we'll be taking the Unit 1 test. It's 50 questions. You'll have the whole class period. It's over these topics: scientific methods, significant figures, scientific notation, measurement, metric system, and converting metric units. So let's go through that stuff. If you were absent or if you were missing assignments for days 9 through 12, this is kind of what we did. Okay. So I kind of put that in there as a resource for students because students are missing some of these stuff. But if you're not completing your daily in-class assignments, you need to be making those up because you won't be passing without completing these. Okay, you've got to be doing your daily assignments. Remember that daily participation grade is a test grade. So if you're virtual and you're not doing this stuff, it's going to be difficult for you to pass. And it's very easy stuff. Okay. Unit 1 test review. Students will watch the video and complete the Unit 1 test review. The video will cover how to solve some of the problems, and then students are required to complete the remaining problems on their own. Okay. Here's the topics again. All right, scientific method. The following steps are required to conduct science or scientific inquiry. Observation. Observe nature and take measurements. Hypothesis. An educated guess that attempts to explain what is observed or measured. This hypothesis must be testable and predictive. Prediction. Predictions are made to test the hypothesis. Experiment. The prediction is tested in a controlled experiment. Conclusions. A conclusion is made from the experiment. The conclusion may support or reject the hypothesis. Okay, that is the scientific method. So let's look at an example of that. So this is an example we did in class where you get up in the morning and you try to get to work and your car doesn't start. So the observation is my car won't start. Question, why won't my car start? Hypothesis, maybe the battery is dead, right? So the hypothesis attempts to explain why the car won't start. And so the battery is one possible scenario, right? It could be other things, but in this case, we're thinking it's the battery. And then we make a prediction. Well, if we think the battery's dead, I predict that if I jump start the car, then it'll start. So get a buddy to come over, give it some power, give it some juice, and it should start. So then the experiment or the test of the prediction is that I actually jump start the car. And when the car starts, I can say that my hypothesis was supported, and now I have proved through the scientific method that the battery was dead. Now you know that you need to have somebody jump start the car so that you can go anywhere, and you need to replace that battery. Now let's say that the battery did not, let's say that the car did not start. Well, then we have to go back and come up with another hypothesis to test. Okay, so we either make conclusions and say, okay, our hypothesis was verified, or we go back to the drawing board. We have to make a new hypothesis to test. Okay, so I want students to do this on their own. Study the 5 statements below and number them in order from 1 to 5, with 1 being the first event, according to the scientific method process. And so we're going to enter the numbers here, and then we're going to write the steps here. So if we go back here, this is our word bank. Okay, 1, 2, 3, 4, 5. There's 5 statements there, right? There's 5 statements there. And so we're going to list them, okay? So put these in order and label them, okay? Should be able to do that on your own. We did this together already. All right, significant figures. If the decimal is present, we say P for Pacific, P for present. And so if there is a decimal present, like this example, 11.2, then we're going to read the number that way. And we're going to look at each digit. Okay, we start counting digits as significant when we hit a non-zero. Okay, we swim through any zeros that we see first. So if it's 0.002 and we read it that way, remember that we swim through the zeros and then we have to count that 2. In this case, we have to count all 3. All right, if there is no decimal, as in 2200, and there's no decimal there, we're going to read it that way, backwards. A for absent, A for Atlantic. So we're going to go from the Atlantic Ocean to Texas, reading it backwards. And remember, we swim through the zeros first, and then we count the 2 after. Okay. Significant figures are the digits, also called figures, in a number that are part of the measurement and contribute to the accuracy of the number. Here are some rules for significant figures. All non-zero digits are always significant. Zeros are not significant if they occur before a non-zero in the direction of the arrow. So if I read the number, right, if I'm reading my number 0.02 and I read that, if I see any zeros first, I swim through them. They don't count. I don't start counting digits as significant until I hit the first non-zero number, and then I count everything after that. So if I had a 1, a 2, and a 0 after that, they would all have to be significant. Okay, all digits that follow a significant figure in the direction of the arrow are by definition also significant. So I've had 2200. Let's add a 0 and a 3 here. So this is 302,000. With no decimal, we would read it that way. So we're moving along, we're swimming. We swim through the zeros, they don't count. We count this 2. All right, read what this says again. All digits that follow a significant figure in the direction of the arrow are by definition also significant. So if we count that 2, we have to count everything that follows in the direction of that arrow. So that would be 4 significant figures. All right, let's try some examples. So here we have a decimal present, so we're going to go that way. And we're going to have to count this 4 because it's not a 0. And remember, you got to count everything after. So it's 1, 2, 3, 4, 5. That's 5 significant figures. This one has no decimal, so we're going to read it that way. We swim through the 4, or swim through the 0, then we count the 4, so that's 1 significant figure. This one has a decimal, so we're going to read it that way. We have to count the 4, and remember, you have to count everything after, so that's 3. This one has a decimal, so we're going to read it that way. We swim through the zeros. We say 1, 2, 3, 4. Okay, remember you have to count these zeros because they occur after a non-zero digit that's significant. So everything after that must also be significant. All right, same thing here. We're going to swim through the zeros, count that. That's 1 significant figure. All right, same thing here. Swim through the zeros, but then these 2 have to count. 2 significant figures. This one has no decimal, so we're going to read it that way. Swim through the zeros, count those 2. That's 2. This one, I don't see any zeros, so they're all significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 significant figures. And since there's not a decimal, we would technically be reading it this way. But since nothing is a 0, they are all by definition significant. All non-zero digits are always significant. Okay, and then I've got this for you guys to do. I'll go ahead and draw the arrows so that you can see which way you need to read these numbers. Okay. So read that one that way. Read that one that way. This one has a decimal, so that way. This one has no decimal, so we'll read it that way. This one has a decimal, so we'll read it that way. Same thing, same thing, same thing. Now this one, this part doesn't count for sig figs, and we're going to read it that way. This part doesn't count for sig figs. We're going to read it that way. That's 4.7. I know the decimal's close there. That's 4.7. Okay, so students need to do that on their own. Just follow the sig figs. Start counting when you hit something that is not a 0, and then count everything that follows. Any zeros that you encounter first do not count. Okay, scientific notation. Some students are getting this, some students aren't, and I think they're tired of hearing it, right? And I'm kind of tired of talking about it as well, but it takes a little bit before we get used to it. But it is a very powerful skill that's going to be used pretty heavily in the class. And so we've got to be able to get scientific notation. So scientific notation is a way to represent numbers with exponents. It is a shorthand notation with a base that is multiplied by 10 raised to some power. The base is multiplied by 10 for each positive exponent and divided by 10 for each negative exponent. So let's look down here. So if I have 1 times 10 to the 1, that literally means 1 times 10 once, and that's 10. 1 times 10 to the 2 is 1 times 10 twice, which is 100. And so we are multiplying by 10, but watch this. We're also taking the decimal and moving it. So if I have 1.0 and I say 1 times 10 to the 1, that's 1.0, and I move the decimal place 1 place over. All right, move that decimal place 1 place over, put it there. What do you got? 10. That's equal to 10, right? Let's do it again. 1.0, move the decimal place 2 times. You add a 0 and then any of these values, look at that, that's 100. Okay, so that's 10 to the 2. So that tells us to move our decimal place that many times to the right. So if it's a positive exponent, you move to the right. If it's a negative exponent, you move to the left. Okay. Kind of like in a number line, right? If you got a number line here, say this is 0. Isn't it positive that way and negative that way? Boom. So if it's a positive exponent, move the decimals that way. If it's a negative exponent, move it that way. And if you can remember the number line, positive is right, negative is left, then you'll remember that, right? 1 times 10 to the 3, 1 times 10 3 times, or 1,000, or watch this, 1.0. Move my decimal place 3 times to the right. 1, 2, 3. Fill in with zeros. We get 1,000. Notice that the decimal moves to the right 1 place for each positive exponent. All right, same thing for the negative. 1 times 10 to the minus 10. 10 to the minus 1 is equal to 1 over 10. Okay, a negative exponent is this on bottom. Okay, and that's 0.1. All right, 10 to the minus 2 is 1 over 10 times 10, which is 1 over 100, which is 0.01. Okay, and the same thing for 10 to the minus 3. It's 1 divided by 10 times 10 times 10. Now let's do it with the decimal trick. If I have 1.0, okay, and I'm doing times 10 to the minus 1, okay, I'm going to move my decimal place one place right there, put it right there. That's 0.1, right? That's what we got before. Same thing. All right, let's do it again. Let's do 1.0. We're going to do 10 to the minus 2. Move that decimal place 2 places to the left. 1, 2, and add a 0. 0.01. That's what we got here. Let's try it for the third one. 1.0. We're going to move that decimal place 3 places to the left. 1, 2, 3. Fill in with zeros. That's 0.001. Now remember the decimal goes right here, and then sometimes we can put a 0 on the other side of that. 0.001. Boom. We get the same thing we got there. Notice how the decimal moves 1 place to the left for each negative exponent. All right, so let's do these. Convert these to scientific notation. So I'm going to do this in a different color. So we've got 100. All right, so remember that scientific notation has to have a number that is not a 0, and then a decimal, and then the rest of the number, and then it's times 10 to some power. Okay, so we want the decimal next to the 1. We have to have the non-zero right there, and then the decimal right after. Okay, so if we look at it this way, this number to the left of that decimal is not a, it can't be a 0. It needs to be a non-zero. So we have to move it. So we're going to move it 1, 2 places. So 1 times 10 to the 2. Okay, so it's a 1 because this is a 1 here, and it's times 10 to the 2. It's always times 10 because it's scientific notation. We're always going to multiply by 10. And then we move the decimal place 2 times to the right. So when you move the decimal to the right, in this case, it's positive, and the left is negative. So in this case, it's backwards from the other one. Okay, but I know that this is a positive exponent because 100 is a large number, and large numbers have positive exponents because you're multiplying by 10 over and over again. It's going to be a big number. Now let's try this one. Let's move this decimal 1, 2, 3. That's 1 times 10 to the third power. Now let's try it. 1 times 10 3 times. Plug that in the calculator. We get 1,000. So we can even check our answer. This is 1 times 10 twice. What do we get? 100. And that's what it should be. So you can always convert back to the decimal form and see if you got it right. Now let's try this one. This one's to the left, so we're going to move it 1, 2. Remember, the decimal needs to be to the right of that non-zero digit. So that's 1 times 10 to the minus 2. Okay, so this is actually 1 out of 100. Or 1 out of 10 times 10. 100th. All right, here's 10. So we're going to move the decimal there once. 1 times 10 to the 1. Now this one, 1.0. If I have 1, I'm going to do 1 times 10 to the what to get 1. If I put a 1 or a 2 or a negative 1 or a negative 2, I'm not going to get 1. The only way to get 1 is to raise it to the power of 0. So you got to remember that anything raised to 0 is equal to 1. 7 raised to the 0 is 1. 9 raised to the 0 is 1. X raised to the 0. It doesn't even have to be a number. X raised to 0 is 1. Okay. 7 million. We're going to move the decimal all the way to 7. 1, 2, 3, 4, 5, 6. 7 times 10 to the 6. Right, I keep that 7 there, and I move the decimal 6 places to the left. Remember that the left is positive, so 7 times 10 to the 6. Or 7 times 10 6 times. All right, and then I need y'all to do these. Convert the following to standard decimal form. So show me the number, right? The full number with the decimal. We did those in class. All right, same thing here. These are standard decimals. Convert these to scientific notation. All right, and put your answers here. Let's see. Actually, I think we were going to do these together. I think I messed up. Okay, so we'll do these together. All right, 5 times 10 to the 3, 5.0. Times 10 to the 3, remember I'm going to go positive that way, negative that way. Think of it like a number line, right? And this is 0. So I'm going to go 1, 2, 3. I add the 2 zeros. I get 5,000. And always rewrite the number. Don't, this can't be your final answer with these here. I can't tell where your decimal is. So rewrite the number with the decimal at the end. Okay, so 5,000. 1.5 times 10 to the negative 3. So let's write it up here. 1.5 times 10 to the negative 3. So 1, 2, 3. I got to fill in with 0. So that is equal to 0.0015. Tiny number. 15 out of 1,000. All right, this one's times 10 to the 2. You see the decimal there? Let's move it 2 places. 745.7. Our decimal is now after the 5, and that's our number. All right, negative 1.5. So I'm just going to do 1.5, and it's a negative 2, so we're going to move it to the left. 1, 2. I'm going to add a 0 there. So that is equal to negative 0.015. The negative here just carries. Just tells us it's a negative number. Okay, remember a negative exponent, 10 to the negative 2, just means 1 over 10 to the 2, or 1 over 10 times 10, which is 0.01, or 1 out of 100. Okay, so this one, these 10, I need y'all to do on your own. Same thing, converting the standard decimal number to scientific notation. Okay, so this one here is 3.25 times 10 to the 2. Okay. This one, same thing, do on your own. All right, measurement. Remember that a measurement always consists of 2 parts. Here's a good test question. A measurement always has a number and a unit. Okay, and here are some of our main units. So for mass, the kilogram. For length, the meter. For time, the second. And we didn't talk about the rest of this, and that's okay. The other one that you need to know is volume. Volume is measured in liters. Okay, this is called the metric system, or the SI system, System International. So metric system, SI system. It's used by all but 3 countries in the world. Okay. Most countries in the world use the metric system. The metric system is a base 10 system. So it's compatible with scientific notation. It's compatible with our the way that we do our numbers. When we move our decimal one place, we are multiplying by 10. So it's all base 10. The difference between one metric unit and the next is multiplying or dividing by 10. There are 3 base units: the meter, the liter, and the gram, and you need to know those. The meter is used to measure length. Its symbol is little m. The gram is used to measure mass, little g. Volume is used, the liter is used for volume, and it's actually a capital L, not a lowercase l. And then time is in seconds. And then check out this video, this website here, for more information on the metric system. All right, so I already have an answer key for this, so I'm not going to do this again. You need to I'm going to give you guys the link to the PowerPoint if you don't have it already, and then you can just have that and copy it over to your warm-up. So you need to put the abbreviations, the meanings, and the scientific notation equivalent for those. There is the metric system prefixes again, but this goes all the way from positive 18 to negative 18. And notice that we have 1 meter here. This can be 1 meter. What else could it be? 1 gram, or it could be 1 liter. Okay, so we start here, 1 meter, 1 liter, or 1 gram. We multiply by 10, we get this unit. Or move our decimal place to the right. We multiply by 10 again, or move our decimal twice, we get there. So once, twice, 3 times. Right, 1 times 10 to the 1, 1 times 10 to the 2, 1 times 10 to the 3. Right down here, 1 times 10 to the minus 1, 1 times 10 to the minus 2. And notice our decimal is moving to the left. Right there. Right, we're adding zeros in front of the number, making the number smaller and smaller. Remember, negative exponents are small numbers. All right, here's our ladder method. You determine the starting point, count the jumps to your ending point, move the decimal the same number of jumps in the same direction. This is the easiest way to do it if you're not a math person. So if I want to go from 4 kilometers to meters, so let's circle where we start. We're going to start here, and we need to go 1, 2, 3. The base unit has got meters, liters, and grams. So if we're going from kilometers to meters, that's exactly what we're going to do. Start here. We're going to move once, twice, 3. And it says to convert to a smaller unit, move the decimal point or multiply. So we're going to start with 4 points. You can put 4.0 if you want. Let's do that, 4.0. We're going to move our decimal place to the right. It says it right there, right? Because we're going this way, aren't we? We're starting here. We're going this way. So we're going to move that decimal place 3 places to the right. 1, 2, 3. Add in our zeros. 4,000 meters is what we get. Okay. If you're going to convert to a larger unit, then you're going to go to the left. So let's try that real quick. So let's say if I was going to go from milli to centi. All right, so if I had 5 millimeters, how many centimeters is that? I'm going to move my decimal place 1 place to the left, right? So 5.0, move it to the left, 0.5. So that's equal to 0.5 centimeters. Boom. Yeah, this is millimeters, 5 millimeters, which would be half a centimeter because there's 10 millimeters in a centimeter. Okay. All right, let's do these here. So 4.89 centimeters. So let's circle the unit we're starting with. We're here, and we need to go to millimeter. So we're doing the opposite of the one we just did. So starting here, we need to go here. We're moving to the right. So let's take our decimal, move it to the right one time. Boom. 48.9. We just got to multiply by 10. 4.89 times 10 is 48.9. All right. Next one is millimeter. So let's erase here, and let's see what we got. Millimeters is here. We're going to micrometers. Uh-oh, micrometers is down here. 10 to the 6th. Okay, so we're going to go from millimeter, which is 10 to the minus 3, to micrometers, which is 10 to the minus 6. Okay, and so we are going from a large unit that way to a smaller unit, right? Smaller unit. And look at the difference between these two numbers. That's a minus 3. That's a minus 6. So that's 3 places. That's 3 jumps. So we're going to move our decimal place 3 places to the left. So 4178. That's our number right here. Right? Our decimal's at the end. Let's move our decimal 3 places to the right. 1, 2, 3. Add the zeros, and there's our answer. So this is 4178. 000 micrometers. So that's 4 million micrometers. Okay. So we use this chart here. Milli is at the end of the scale. And I think we should take this and actually expand it to include these other units. But this is just the 2 pictures I have. So this has got milli, which is 10 to the minus 3. And then if you keep going, the next unit is micro, which is 10 to the minus 6. Okay, so the difference between those two is 3 jumps. Right? What is 6 minus 3? It's 3. So there's 3 jumps between them. So we move our decimal place from here at the end of the number 3 places to the right. Okay, next one. Kilogram. Killi's right here. Kilogram is 10 to the 3. Oh, we're going to go to picogram. Pico is not here. Pico is down here. It's 10 to the minus 12th. So picogram, 10 to the minus 12th. Think of this like a number line. We're starting at 3. So here's 3. We got to go down to 0. Right? And then we got to go way down here to negative 12. So you ask yourself, how many jumps is it from 3 all the way to negative 12? Okay. So to get from 3 back to 0, that is a jump of 3. How many steps to get from 0 to negative 12? It's 12, right? And so how many total jumps? 12 plus 3. So the difference between these two units is 10 to the 15. 12 plus 3. 15 jumps. Okay? So we're going to take this 1.6 and we're going to move our decimal place 15 times. So 1.6, 15 times, 1, 2, 3, 4, 5. Good God. And that's our answer. And some of these, you can actually do a little trick here, guys. If you want to check yourself, you can go onto Google. Okay. And our question here is 1.6 kilograms to picograms. Let's type that into Google. 1.6 kilograms to picograms. What? Just like that. 1.6 kg to picograms. It'll tell us that. 1.6 times 10 to the 15. Right? We had 1.6. We moved our decimal place 15 places to the right. So it's 1.6 times 10 to the 15. So that's what we're going to write. 1.6 times 10 to the 15. I'm not going to write this giant number, right, with all the zeros. Okay. Next one. 98 centigrams to deci. We can use this chart here. Here's centi. Here's deci. So we're going from here to here. So we're doing this. We're going to move the decimal place to the left. So 98 with the decimal right there. Let's move it to the left one place. Boom. 9.8. Done. All right, next one. Liter is, let me erase here. Liter is right here. This is the liter here, right? You see the 3 units, it's the base unit. Liters is right there. We're going to go to milli. We're going to move 1, 2, 3 places to the right. So 0.713. Move our decimal 3 places to the right. 1, 2, 3. So we get 713 millimeters. Because now the decimals there. This is gone, and now it's 713 with the decimal right there. Awesome. All right, and I've got some for you guys to do. I'm going to go through here and read them out loud. So if you need help, this is meters, which is the base unit, to kilometers. Meters to kilometers. I'll even show you that. So here's our meter. Here's kilometer. We're going to move our our decimal 3 places to the left. 1, 2, 3. 0.03 kilometers. All right, this one is millimeters to picometers. So let's look at that. Millimeters is right here. And actually, I'm going to look at this chart. Millimeters here, 10 to the minus 3. And we're going to do picometers, which is 10 to the minus 12. So remember, we're going 10 to the minus 3 to 10 to the minus 12. What is the difference between 12 and 3? And the answer is 9. So you need to move your decimal place 9 times. And you're going to a smaller unit. So you're going to move it to the right 9 times. So your decimal's there. Move it to the right 9 times. Write your answer in decimal or scientific, whichever is more fun for you. Kilometers to decimeters. Kilometers is here. Deci is there. So we're going to be moving it to the right 1, 2, 3, 4 times. Next one, kilo to centi. There's kilo. Here's centi. Move your decimal 1, 2, 3, 4, 5 times to the right. Okay, so that one's good. That's the ones we got so far. Oh, here's a cool one. Kilo to micro. Kilo is 10 to the 3. Micro is 10 to the minus 6. So that is a difference of 9. And we're going to a small unit. So we're going to move our decimal to the right 9 times. Next one, nanograms to decigrams. Nano is 10 to the minus 9. And deci is 10 to the minus 1. So that's a difference of 8. So you're going to move your decimal place 8 times to the left because it's a bigger unit that you're going to. So take 5.2, move that decimal place 8 times to the left. Okay. Next one, liters to nanoliters. 1 liter is 10 to the 0. Nanoliters is 10 to the minus 9. All right, and we're going to a larger unit, so I'll move your decimal to the left. So take this decimal here, move it to the left 9 times. All right, next one, megaliter. What the heck is a megaliter? 10 to the 6th. So we're going to go from 10 to the 6th to a liter, which is 10 to the 0. So essentially we're going from way up here all the way down And so we're going to move to the right 6 times. So move your decimal place right here, 6 times to the right. Okay, next one. These are so much fun. 19 deciliters. So deci is right here. We're going to go to centi, which is right here. We're going to move our decimal place to the right once. So move the decimal place to the right. It's 190. That's easy. 12 gigaliters. Giga is 10 to the 9. Milli is 10 to the minus 3. So how do we get from 9 all the way down to minus 3? We have to go from 9 down to 0, and then 3 more to get to negative 3. So that is a jump of 12. And we're going from a large unit to a small unit, so we need to multiply. So we're going to move our decimal place 12 times to the right. Okay. Dimensional analysis. So I have a question on the test over this, and it's actually this one right here. You just need to be able to set it up, okay? Or pick the one that's correct. Which setup would be correct? So we're converting from 3 meters to millimeters. So what do we need to do? We need to write 3 meters over 1. Okay, and then I know that there's 1,000 millimeters in 1 meter, right? And so I'm going to write that 1,000 millimeters. I'm just going to put milli over 1 meter. Notice that the meters cancel out. Meters is on top, meters is on bottom. Anytime you have something on top divided by something on bottom, like 1 divided by 1, you cancel out, you just get 1. Or 9 divided by 9, you cancel out, and you get 1. All right, so anything divided by itself is 1, so it just cancels out, disappears. So what are we going to do? 3 times 1,000 is 3,000. And what is our unit for our answer? It's going to be millimeters, because the meters is gone. This is gone. All that's left is millimeters. So 3,000 millimeters. Boom. Okay, so here's the one that I need you to do. Pick the correct one. And like I said, this one will be on the test. Okay, but you guys have the question there. And that's it, folks. Thanks for watching. Have a wonderful day.